Hello children, this is Chalkbox, Class 10 Mathematics, Assertion and Reasoning Questions, Chapter 1 Real Numbers. In the current question paper pattern, we have Section A 20 MCQs. In those 20 MCQs, question number 19 and 20 is given as Assertion and Reasoning questions. Many of us have a misconception that this assertion and reasoning question is such a way assertion is one part and reason is the continuation of the assertion part. And assertion and reasoning is like question and answer. It is not like that. Assertion and reasoning are two different statements. We were given four options. In what way these two statements have a connect within them. In that, this option 1 says both A means assertion, R means reason. Both A and R are true. Individually, we have to read the assertion statement and the reason statement, find out whether the statement is true. And this first option also says R is the correct explanation of the assertion. So, this assertion and reasoning have a connect with them. The reason can be a explanation. It explains the assertion in a proper way. Option 2 says both A and R are true, but individually the assertion is a true statement, reason is a true statement, but they are not explaining or they are not connected to each other. Such statements are given means you can go for option 2. Then option 3 is A is true, assertion is true, but reason is false. Option 4 is assertion is false, but reason is true. So these are the four options given in the assertion and reasoning questions. If you go through this option, you can find a simple trick to solve such questions. What is that trick? See, first two options, both the statements are true. But when you go for option 3, reason is false. You go for option 4, assertion is false. So, the very short trick and important tip to solve this A and R question is just first check the reason statement. If reason is false, option 3 is the only answer. Choice 3 is our only answer. We can choose that answer. Then, suppose if R is true. If R is true, go and check A, assertion. If assertion is also true, then check the connect between them. So, first check the reason. If it is false, select option 4. If it is true, check assertion. If assertion is false, go to option 4. If assertion is true, you have two options. You have to check the connectivity between those two statements. If it is an explanation to one another, it has a connect, go for option A. It has no connect, individually they are true, means go for option 2 or B. Okay, so this is the way you can solve this assertion and reasoning question. Okay, when we talk about the connect, the link between these two assertion and reasoning question. Now you checked assertion is also true, reason is also true. You wanted to check the connect between these two statements. How do you check? How can I assure that it has a connect? Okay, for that I'll give you a simple trick, cute trick. What is that cute trick? C stands for connect, U stands for use, T stands for tells, E stands for explain or elaborate. That means the reason should have a connect with the assertion. Suppose a question is given. I am finding a simple interest for this much amount. This is the interest. This is assertion. In the reason, they were given a simple interest formula. So these are the two statements. When you calculate it, the given interest rate is correct. So assertion is correct. Then the formula is correct. The reason is also correct. As the assertion statement used this interest formula and calculated the interest, it has a connect. What is that? Used. Reason is used in the assertion. Such a case, you can say R is a correct explanation of A. You can go for option 1. Okay, like that, the reason should have a connect with the assertion, or the assertion should have used the reason, or the reason should tell about the assertion or explain about the assertion in an elaborated way. Okay, so this is a simple trick you can remember to solve this assertion and reasoning questions. Now we go for practice questions. Question 1. Assertion. The HCF of two numbers is 80 and their product is 3072. Then their LCM is 169. Reason. If A, B are two positive integers, then HCF into LCM equal to A into B. So we have four options. First we have to check the reason, because reason is the explanation of assertion. Should be an explanation of assertion. So check the reason. We can very well declare that reason is true because it is a standard equation to verify the relation between two numbers and their LCM and HCF. So reason is true. Once reason is true, go for checking the assertion. Assertion, they gave HCF and the LCM. Just find the product of HCF and LCM. We can find this product is 18 into 169, which is 3042. But it is declared that the product of the numbers is 3072. The product of the two given numbers should be equal to the product of the LCM and HCF. That is what the statement says. So this is not equal. So assertion is false. When assertion is false, we go for option D, which states assertion A is false but reason R is true. Here you will get a doubt that I have checked assertion A. Should I check the reason also? Obviously, you would have checked the reason first. Then only you go for assertion. So, directly we can declare. Suppose if the reason is false, should I check the assertion also? It is not necessary, because if any one statement is false, we have option C and option D, in which any one statement is false. Such a way only the question will be given. Any one is false means you need not check the second one, because the other statement should be true. Only when both are true, you have to check whether they have a connect between the two statements given, or there is no connect. Individually the two given statements are true. Okay, so this is the conclusion. When any one statement is false, you need not check the other statement, just confirm that it is false. Then accordingly you opt whether reason is false, go for C. When assertion is false, go for D. Question 2. 12 power n ends with the digit 0, where n is any natural number. Reason. Any number ends with the digit 0 if its prime factor is of the form 2 power n and 5 power n, where m and n are natural numbers. This is nothing but the fundamental theorem of arithmetic. So the reason is a true statement. We check it with the assertion. 12 power n. So according to FTA, what we do, we just find the factors of 12. Factors of 12 is 2 into 2 into 3. So I can understand there is no 5. There is no 5. If only I have 5, I can take this 2 into 5 as 10. When it is multiplied by 10, obviously it ends with 0. So as there is no 5 present in this product, 12 power n, for whatever natural number may be the power, it doesn't end with 0. As they declare it ends with 0, Assertion is a false statement. Only reason is true. If any one is false, we go for either option C or D. As assertion is false, select option D. Question number 3. Assertion. 3 is a rational number. Reason. The square root of all positive integers are irrational. Just take root 4. What is the value of root 4? We know it is 2. Right? 2 is not an irrational number. 2 can be written as 2 by 1. So it is a rational number. So the statement fails. It is a false statement. So once the reason is false, you need not check the assertion. Directly go to option C, which states that the assertion is true but the reason is false. Question 4, assertion says that 18, 25 is a pair of co-primes. It's a pair of co-primes. First of all, 18, okay, it's a pair of co-primes. Go and check the reason. First, you should know what is co-prime. Co-prime means the numbers have the common factor 1 only. Only 1 is the common factor. Here, 18 and 25 have a common factor 3 also. So, first you check the reason. As I said, here it is given 2 is a common factor. Here itself the statement goes wrong. When the reason is wrong, we obviously take option C. Question 5, assertion. Denominator of 12.145 when expressed in the form of P by Q is of the form 2 power n, 5 power n, where m, n are non-negative integers. So, they are telling that number 12.145. When you find the fraction form of this number, you will be writing 12.145 by 1000. If you simplify that, the denominator will be in the form of 2 power n. Obviously, 1000 can be written as 5 into 2 into 5 power and 2 power. Like that, you can write it. The denominator can be written in the form of 2 power and 5 power. So, assertion is true. 12.145 is a terminating decimal. Yes, there is no expansion given, no bar is given, no repetition is there. So it is a terminating decimal expansion. Reason is also true. And when both the statements are true, you have to check with the cute rule. What is that cute rule? Assertion is telling about the denominator, which form of denominator is having a terminating decimal. Reason is telling the given number itself is terminating. Of course, assertion 12.145 is a terminating decimal. That is what reason is also telling. So, the reason tells about the assertion. So, it is a option A. Assertion question 6. 29 by 625 is a terminating decimal fraction. If reason, if q equal to 2 power n, 5 power n, where m and n are non-negative integers, then p by q is a terminating decimal fraction. The factors of the denominator. R is a true statement. It is a property. It is a theorem. Standard rule. So it is true. Now check the assertion. 29 by 625. Find the factor of 625. 625 have a decimal expansion as 2 power 0 and 5 power 4. 5 times 4 is 625. So as it is in the form of 2 power and 5 power, it ends, it terminates. So assertion is true. And the assertion is using the reason 2 power and 5 power and formula. So we go for option A, which states that A is true, R is true, A is a correct, R is a correct explanation of A. Question 7. Question 7. The assertion is 3 into 5 into 7. It is not into plus. Be very careful about this type of question. First you have to find out where plus symbol is available. Because before the plus symbol, this group of numbers are one part. And after the plus symbol, if any other number is there, that is the second part of the given number. And the reason is, a composite number has more than two factors. Now, the reason is a true statement. Now you check the assertion. Just take this 7 common. Take this 7 common. Then the number become like this 7 into 3 into 5 into 1 plus 1. Now 1 is a factor to any given number. The number itself is a factor to any given number. So two factors are there for any sort of number. Now we have taken 7 as common. So the number can be divisible by 7. So 7 is the third factor now. As you have one more factor more than 2, it is a composite number. So assertion is also true. Here this assertion is using the reason, the statement to be a composite. So it is using this statement. So we go for option A. Assertion: root x is an irrational number where x is a prime number. It means when any prime number comes under the root, it is an irrational number. Yes, we know this statement is true because root 3, root 5, root 7 are all irrational numbers. Now the reason is, square root of any prime number is an irrational number. This is what I explained just before. So this is a true statement. Reason is true. We checked the assertion by putting some value in place of x. That is also is true. And this assertion is talking about irrational of a number which is inside the square root. It should be prime. Here also the number is inside the square root, that number is prime. So both are explaining each other. So we go for option A. Question number 9. Assertion: the decimal expansion of the rational number 33 by 2 power 2 into 5 will terminate after 2 decimal places. The reason: the rational numbers are those numbers that exist in the form of p by q, where p and q are any integers. This reason is telling about a statement which explains about a rational number. So any rational number can be written in the form of p by q, where q should not be 0. So the reason is a true statement. Assertion says that 33 by 2 power 2 into 5 power 1 will terminate after 2 decimal places. Yes, here I have 2 power 2. Suppose if 5 is also 5 power 2 means I can write it as 10 power 2. 10 power 2. So number 33 will be divided by a number 10 to the power 2. So 1000. So it terminates after, 10 power 2 is 100. So if you divide number 33 by 100, you will get 0.33. You will get 0.33. So this decimal terminates after 2 places. So whenever you have a denominator 2 power and 5 power n form, find the highest power. Suppose it is 2 power 2 and 5 power 3. The number will terminate after 3 places. Okay, that is the logic. So A is also a true statement. But when both are true, we have two options whether they are explaining properly to each other or not. So we will check that connect between these two statements. Here the reason is talking about rational number. Assertion is talking about terminating decimal place. So both are little different things. The reason is not used. and the reason is not explaining the assertion, not connecting the assertion. So we go for option B. Question 10. 2 minus root 5 is an irrational number. The sum or difference of a rational number and an irrational number is a rational number. Irrational number. That means if you summate or subtract a rational number and an irrational number, or an irrational number and a rational number, the result will be an irrational number only. So it is a true statement. Reason is true. So 2 minus root 5, that means I subtracted an irrational number from a rational number. So obviously the result is also an irrational number. So the reason supports, that means explains or elaborates the assertion. So we go for option A. Hope this video will be helpful to you children at the eve of your exam days. So just go through this video and understand. I have designed these questions. I have arranged the question in such a way that when you solve this assertion and reasoning question, you will practice almost all the concepts of this chapter are covered in the same sequence. So it will be helpful to you not only for this 1 mark but also to do 2 marker and 3 marker and recall the content also. All the best for your exams. Thank you.